Hey there, class. Thank you to your classmate who asked me about this question on your homework regarding relative standing and box plots. This question, or this type of question, requires a little bit of algebra, so I just wanted to walk you through solving for a number when you are given some values. So let's take a look at this problem. We know, based on the information presented in section 3.3, that we should be considering a value to be significantly low if the z-score is less than or equal to -2. So the z-score less than or equal to -2, not the data value, or significantly high if the z-score is greater than or equal to +2. Now, our question here is, what is the score that would be significantly low? The test score, not the z-score, okay? And so here we've been given an x-bar, our mean test score is 19.9, and an S, standard deviation, of 4.6. So if we use our formula, z equals x minus x bar over S, we can understand how to find the test score that corresponds with the threshold for significantly low and significantly high. So if we use that formula, a significantly low test score has a z-score of -2 or less, right? So what we're going to do is we're going to substitute in -2 for z in our formula. All right, so -2 equals x minus, now we know x bar is 19.9, divided by, we know what S is, which is 4.6. And so if we now take this and solve for x, right, because x is going to give us the actual test score, we will be able to find out what is that test score, which indicates the threshold for significantly low values. All right, and so in order to solve for x, what we have to do is first multiply both sides by the denominator here, 4.6. 4.6, you're going to get, what's that going to give you? -9.2 equals, and so when we multiply by the denominator, what happens is it cancels the denominator, right? And so we're left with, on the right side, x minus 19.9. Add 19.9 to both sides, and we get our x value. So our x value for significantly low test score is going to be, for a z-score that's -2, which indicates values beyond which the test scores are significantly low, is going to be, what is this, 10.7, I believe. Okay? And so x equals 10.7 gives us test scores that are significantly low. Any test score that is less than 10.7 should be considered significantly low because that corresponds with z-scores that are less than -2. Alternatively, what we can do is find z-scores that are significantly high. And I'm sure that is the next part of this question, which I didn't copy. All right? And so I want you to notice that this question is actually a multiple choice and a fill-in-the-blank question. All right? So we have to choose answer choice A and fill in the number corresponding with answer choice A. All right? So if we were asked which test scores are significantly high, we would do this calculation again. All right, using our formula, x minus x bar, let me make this the same as the other one. Significantly high, we're looking for a z-score that is +2 or greater. All right, and so what we're going to do is we're going to substitute +2 into our z-score formula. X is still our unknown. We know x bar is 19.9. We know S is 4.6. And so again, we're going to be solving for x, all right? Because we're solving for x because we need to find the data value associated with this z-score of +2. All right, so do that process one more time. All right, we're going to just copy this over. You can see it nice and clean. Oops, 19.9. We're going to multiply both sides by the denominator, 4.6. It's going to cancel our denominator. On the right side, it brings it over to the left side. All right, and here we have a positive 9.2 equals x minus 19.9. We're going to add 19.9 to both sides. Oopsies. And we're going to get x equals, what is that? 30.1, I think? X equals, wait, 10, 29, 28, 29.1, I'm sorry. X equals 29.1. That, any value greater than this is considered significantly high because this test score of 29.1 is associated with a z-score of 2. I hope that helps to explain how we're going to find specific data values that give us specific z-scores. All right, good luck on your test this weekend. Toodaloo.